I'm ready for it. Should we start the intro or something? Or hi, welcome to Miss Kasiyama's YouTube channel. Woo! I'm Mr. Loomis, and that's
I'm
Miss
Miss
Kasiyama.
Kasiyama.
Yeah.
Hey guys, I hope you guys are doing well. Before we get into our lesson though, we have a special guest who's going to teach us some geography.
Yeah, and today we're going to show you guys a little bit about some Japanese geography. Miss K, you ready for this?
I'm going to try.
All right, well, let's go ahead. I'm going to do the screen share here. Get this map up. All right, here we go. So it's asking you, where is Okinawa? Oh, I don't know. Oh, Shikoku.
Oh no!
No!
Oh my god, I'm so terrible. I'm ashamed.
All right, next one is Kyushu. Oh, we saw that one already. Is it this one? Or is it this one? I forgot. I don't know. Left or right? I think it's this one. Yes. All right. Oh, Shikoku. Is it this one? Yeah, okay, good. Okay. Chubu. Which one's Chubu? That one? No. Did I say this again? Did we get Chubu already? No, I think we did. I think that one. Ooh, okay. Oh, man, we're on fire. 4 in a row. Okay, Kinki? Kinki. That one. This one? Yeah. No, that's Chugoku. This one? Yeah. Chugoku.
Oh, okay. So we got 60%. D minus. Woo!
Yeah, go
Passing.
us! Maybe we have to stick to math then, Mr. Loomis.
I think so. Yes, on that note, let's learn some math.
All right, guys, we're going to take some notes then.
Go.
All right, guys, I'm not good at geography, so that's a no. We're going to do something I am good at. Let's go ahead and do some math. All right, guys, today we are going to do a pretty quick lesson. We're going to finish up chapter 12, which again, the focus has been on polynomials. We've seen adding, subtracting, we worked on multiplying. The last thing that we're actually going to be taking a look at though is going to be multiplying trinomials. And then next week we'll put together these different concepts and look at it with a real life application. But today, again, the focus is multiplying trinomials. So if you're still following along in your table of contents, you can go ahead and add that. All right, so in our notes, we're going to go ahead and put some examples of what multiplying trinomials look like. The good thing is that it's actually the same idea as multiplying our binomials that we saw last week. All right, so we'll go ahead and start with an example. Let's say we have a problem that looks like this. Let's say we have 2x plus 3, and we are going to be multiplying that by, let's do 3x squared minus 4x plus 5. All right, and so the difference here is that we are still going to be multiplying. You can tell because our parentheses are right next to each other. But this time, instead of multiplying a binomial by a binomial, we have a binomial times a trinomial. So you'll notice that we have square term, we have an x term, and we have a number. So we're going to be multiplying by 3. Now, I'm going to show you again those same two methods that I showed you last week. So either using our table or our double distributive, and they're going to work just as well here. So let me go ahead and show you with a table first. So just like last time, table method. How you would set up your table though this time is it would actually be a little bit bigger. And so what I'm going to do here is I'm going to take our problem and I'm going to break it up like we did last week. So I have this 2x and a positive 3. And so I'm going to go ahead and put that on the side. So 2x and then positive 3. All right, the difference is going to be though with this term here. This term, unlike last week, we have 3 terms though. So again, we have our 3x squared. So we'll go ahead and put that in one of our spots. So 3x squared. Again, take the sign here. We have a negative 4x, so minus 4x. And then we have this positive 5, so we're going to go ahead and put plus 5. All right, what you'll notice is that the table, again, it looks similar. We just kind of have an extra column now added to this. But you're going to do the same thing that we did last week. So you're going to multiply what makes up this box. So here you would do the 3 times 2, which would give us 6. And then you would also do your x's. X to the second times x. And again, please remember here you're adding those exponents. So I have 2 x's and then one more is going to give me x to the third. So really just watch the exponents here. All right, so same thing, next box, we would do number times number. So negative 4 times 2, so negative 8. And then letter times letter, x times x, and that's going to give you that x squared. And then here, last box, number times number, 5 times 2 is going to be 10. and then again, keep your variable of x. All right, and let's go ahead and do to the bottom row here. So number times number, 3 times 3 is 9. This time you're going to keep an x squared. Next box here, number times number, negative 4 times 3. So again, watch your signs, negative 12. Keep your x. And then the last one here would be 5 times 3, and that's going to give us 15. All right, your last step though here, just like we saw last week, is going to be to combine any like terms you can. So what you'll notice is the boxes that are diagonal. So we have an x squared here and an x squared here that can be combined. Likewise, you're going to notice that we have an x here and an x here that can be combined. So let's go ahead and simplify this problem then. So you'll notice that we only have one set of x to the third, which is 6x to the third, so we're going to keep it. Go ahead and combine your x squares. So you notice here that you have a 9x squared and a negative 8x squared. That is going to combine to a positive 1x squared. And again, remember, you want to put the operation sign in between it. So it is a polynomial, so all these terms are separate. It is a positive one, so I'm going to go ahead and put a plus. All right, let's go ahead and do our x's now. Here you'll notice that we have this negative 12x and a positive 10x. Again, we are combining, so that's going to combine to give us a negative 2x. And then you'll notice here 15 has nothing to combine with. So we're going to go ahead and add that to the end. And again, put in that sign. So it is positive. So we're going to put that plus right there. All right. So hopefully you guys noticed a couple differences here though. Notice that unlike last week, your answer actually has 4 terms. And that's going to happen when we have this trinomial that we're multiplying by. Notice that the exponent is a third or a cubic here. So again, watch for that. And then again, last thing that I'm going to point out to you guys is remember that these are not like terms. X to the third is different from x to the second, which is different from x, which is different from 15. So you cannot combine it. And so in this case here, this would be your final polynomial. 6x to the third plus 1x squared minus 2x plus 15. So that would be my final answer here. Hopefully that makes sense. All right, let's go ahead and take a look at this problem though with distributive, and then again, you'll notice that we'll get the same answer. So let me go ahead and scroll this up. So this is going to be the method for those of you who like the distributive method a little bit better. So distributive. All right, so here is that same example that we just did in the last problem, but this time we will solve it with our double distributive. And so please remember that when you are using double distributive, you're actually only going to be distributing this first term. We'll start with our x's though. So here we're going to take that first term, which is 2x, and it's going to get distributed to our first term here. So same thing we saw with the table. So number times number. 2 times 3 is going to give you 6, and then x times x to the second. Again, remember you're adding. It's going to be x to the third. Right, so same thing here. Please remember here that you are taking the sign though when you distribute to that second term. So again, number times number. So number times number. 2 times negative 4 is going to be negative 8. And then x times x is x squared. And then again, you're going to take that 2x times 5, so number times number, 2 times 5 is 10, and then keep the x. And then again, remember that all these terms are going to be separated. We want to put in our operation sign, so it is positive, so we will put that plus sign there. All right, let's go ahead and distribute that second term. So again, this is why it's called double distributive. This time you're going to take that 3, and you're going to go ahead and distribute it to all 3 terms inside the second parenthesis. And so same thing here, 3 times 3 is going to be 9, and then x squared. You're going to notice here that I lined up my x squares just like I did last week, and that just helps me visualize that these 2 terms can be added together. I'm going to take my 3 right here and multiply it by, the negative 4, so negative 12x. And then 3 times 5 is going to be that positive 15, so plus. And again, add in that plus sign right there. All right, remember this is a big adding problem when we combine it. And so combine the like terms. So with the x to the thirds, I still have 3 of them. I'm going to combine my x squares here. Negative 8x squared plus 9x squared is going to give me positive 1x squared. And again, positive is going to be represented by the plus sign. 10x and negative 12x is going to be negative 2x. And then this 15 has nothing to combine with, so then plus 15. All right, and again, what you should notice, let me go ahead and zoom out a little bit, is that you end up getting the same answer here. So whatever method works best for you or is preferable to you, then that's the way that you should solve this problem. All right, but like any other lesson that I give you guys, I'm going to go ahead and give you guys an example problem to try just to make sure that makes sense. I am going to put some negatives in here so that you can watch for those signs. So here is the problem for you to try just to make sure that you have this idea down. Let's go ahead and we will multiply. Let's do larger numbers this time. 6x minus 8. And then let's multiply that by, let's do 3x squared minus 10x minus 4. All right, so again, this time you'll notice that I gave you guys a handful of negative signs. So try that problem. I'm going to go ahead and set it up also, and then we can see if your answers match mine. All right, go. All right, guys, how did you do? So I actually did it both ways for those of you who are using the table and for those of you who are using distributive. The answer you'll notice is the same. And again, you'll notice here that you do have those 4 terms. So again, watch those exponents and make sure that you are adding them and that value, that exponent is not changing. But final answer here ended up being 18x to the third minus 84x squared plus 56x plus 32. All right, and so that is our last lesson then with our multiplying, and that's what happens when you have a trinomial added in. I want to show you one final thing and then prepare you guys for essentially the end of our chapter quiz. So I'm going to go ahead and scroll this up. You will see this more so as a bonus problem, but I will encourage some of you guys to challenge yourself. Let's say that you saw a problem like this. 5x squared plus 2x minus, let's say, 8 times 2x squared minus 6x plus 1. All right, what I want to show you is that this is still a multiplying problem. Again, you can tell because our parentheses are right next to each other. But the difference here is you actually have a trinomial times a trinomial. So notice 1, 2, 3, 3 terms here times 1, 2, 3, 3 terms here. All right, and so here, if you did see a problem like this, you would actually do the same thing. You could do triple distributive. What's happening here is that instead your 5x would get distributed. Your 2x would get distributed, and also your negative 8 would get distributive. So it becomes a little bit more lengthy in work, but you guys could solve it. So it's the same idea. Those of you who like to use the table method, what would happen is that you would just have a really giant table here. So if you ever came across something like this, I'm going to tell you guys that you have the skills to solve this, so you can definitely do this. So again, those of you using the table, it would become kind of like this tic-tac-toe board, and what would happen is you would break up your problem. 5x squared, you have this 2x here, and then you have this negative 8 that you can put there. And then same thing, you would break up this one too. So we have a 2x squared We have a -6 here, and then we have a +1 there. So in the case that you did see something like this, you guys could definitely solve it. All right, guys, that wraps up all the skills that you need to know for this section. All right, guys, that's it for our lesson. I will see you guys next week. As always, email me if you guys have questions or come visit us on the Zoom. All right, I'll see you later. Thanks for
Nice.
joining us, Mr. Loomis.
It's so good to be here. Thanks for learning some Japanese geography with me.
We'll have to try again next time.
Yeah, we'll do it again next time. Cool.